Our next example is a function h of x that is x to the fifth plus 5. So this again, another polynomial. X to the fifth is a power function that looks just like x cubed and x to the seventh and x to an odd positive integer power. This one with the plus 5 has been shifted up 5 units, so it has the same basic shape as our old friend x cubed, shifted up 5 units. And I don't see any maxes or mins on this function. It looks like there might be an inflection point when x is 0, but my goal again is to find critical values, maxes, mins, and inflection points. So I start with finding h prime, and again it's a simple derivative, but I ask Mathematica to find it for me, and then I solve, setting that derivative to 0, and I get one root at x equals 0, but it's repeated. It's a quadruple root. And here I'm using the table method of the first derivative test, where I see h prime is positive. Whoops, I meant to switch back to black there. H prime positive, that means h is increasing. Then h prime positive again, meaning h is increasing. So I have a horizontal tangent line when x equals 0. H prime of 0 is 0. And to the left of that, f prime is positive, f is increasing. To the right of that, f prime is still positive, f is increasing. That's what I found in, sorry, these are h, not f. Hang on. Wonder if I did that in the last one. I don't even want to look. I hope you'll forgive me if I did. Whoops, and this isn't G either, it's H. So what I see in the table is confirmed in the graph. H is increasing where h prime is positive and has a horizontal tangent line where h prime equals 0. Then I look at the second derivative and I set that to 0, and I have also x equals 0 as a solution, as I did with the first derivative, and it's a triple root. And I look at the sign with a table of values. I look at the sign of h double prime to the left of 0, and that sign is negative, so h is concave down. I look to the right of 0, and I see that h double prime is positive, so h would be then concave up. So that means I have a point of inflection on h at x equals 0, which is what I suspected from looking at it, just eyeballing it. Point of inflection on h, no maxes, no mins. So I had places where the first derivative is 0, well, one place, but it turned out not to correspond to a max or a min, and that does sometimes happen. So you don't want to assume that just because you found where the derivative is 0, that means there has to be a max or a min there. If the first derivative is 0, that means the tangent line is horizontal, but that doesn't automatically mean there's a max or a min.